What is ligand, man? See, in important terms in coordination compound, the main important one is ligands. What is ligand? Ligand is nothing but it is the molecules or ions, maybe positive and negative ions. Okay, molecules are nothing but neutral. Neutral molecules are ions which can donate pair of electrons. Which can donate pair of electrons to the central metal atom, forms day2 bond with central metal atom. Means ligands are nothing but it is an ion or molecules can donate pair of electrons to the central metal atom, can form day2 bond called as ligands. Okay, so according to Lewis acid base theory, electron pair donors are called as Lewis bases. Electron pair acceptor is Lewis acids. So central metal atom or central metal ion accepting pair of electrons from ligands. Accepting pair of electrons from ligand means central metal atom or central metal ion acts as a Lewis acid. Ligands are also called as Lewis bases. Ligands are also called as Lewis bases. So ligand, what is the characteristic or main property of ligand? Ligands nothing but it is the atom or molecules or ions can donate pair of electrons to the central metal atom or central metal ion, and it can form day2 bond with central metal atom called as ligands. So ligands also called as Lewis bases. They act as a Lewis bases. Okay, is it clear? Now, what are the different types of ligands present or classification of ligands? Ligands are mainly classified into 3 types. Main types are 3. So what are those 3 types of ligands are present? One is based on the charge, second one is based on the number of donor atoms, the third one is based on the nature of bonding with central metal atom or central metal ion. Means the third one is nature of bonding. See here, I explained 2 types. One is based on the charge. The first classification is depends on based on charge. So based on charge, the ligands are classified into 3 types. So based on the charge, ligands are classified into 3 types. One is neutral ligands, second one is negative and positive ligands. Neutral, negative and positive. Neutral, negative and positive. It is very clear. Based on the charge, ligands are classified into 3 types: neutral ligands, negative ligands and positive ligands. So neutral ligands example. Neutral means there is no charge. Means molecules. Ammonia, water and carbonyl group, CO and pyridine. See here, nitrogen is donor atom. Pyridine, PY. Pyridine. Now negative ligands, halide ions, chlorine, bromine, chloride ions, Br minus, I minus, cyanato, sulfate ions, carbonate ions. Those are positive ligands. Positive ligands means NO plus, NO2 plus, H3O plus. These are called as positive ligands. Means they have positive charge. Positive charge present on the ligand. Those are called positive ligands. Generally, positive ligands are very less. Mostly ligands are maybe neutral as well as negative. Neutral ligands are negative charge. They have negative charge. Now, based on the donor atoms, for example, the ligand has one donor atom is present, it can able to donate 1 lone pair electrons or 1 lone pairs. Means if it is donate 1 lone pair, those are called monodentate ligands. Denticity. What is the meaning of denticity? Denticity means the ligand can donate how many number of electron pairs. If the ligand can donate 1 lone pair electrons to the central metal atom, means it contains 1 donor atom is present. Hence its density is 1. If a ligand can donate 2 lone pair electrons, then its density is 2. Means it contains 2 donor atoms are present. So based on number of donor atoms, if a ligand having 1 donor atom is present, it can donate 1 lone pair electrons to the central metal atom. Those are called monodentate ligands. Monodentate ligands can donate 1 pair of electrons. 1 lone pair it can donate 1 pair of electrons. Okay. What are the examples? See these monodentate ligands also. Again, they have negative charge, have positive charge as well as neutral. See some examples. It is intermixed all I give. Cn minus. Generally, negative ligands are present while writing its IUPAC nomenclature of the complex compound. The negative ligands ends with O. Commonly, one end, the one letter is coming in their name. Ends with O. Okay. Cn, cyano. Cl, chloro, bromo, iodo. SCN, thiocyanato. Okay, CH3COO minus acetate ion. Generally it is acetate ion, but its name we have to pronounce for complex compounds. It is acetate. OH minus hydroxo. Okay, NO2 minus nitro. NO3 minus nitrato. ONO minus means here oxygen is donor atom. Means oxygen forms bond with central metal atom or central metal ion. That's it is called as nitrito. Nitrito. NH3 is called amine. NH3 is called amine. AMMINE. While writing the IUPAC nomenclature of NH3 in complex compounds, amine. AMMINE. Amine. Very important one. H2O called as aqua. CO carbonyl group. These are neutral ligands. Nitro NO group. NO group is present. It is called nitrosyl. C6H5N pyridine. The symbol is PY. Some of the ligands have some symbols are present. PY is called pyridine. See here EN. Where is EN? EN means ethylene diamine. Shortcutly it is represented as EN. No need to write its formula also. EN is present in the complex compounds. Then it is called ethylene diamine. OX is present. It is called oxalate ion. Means its formula is C2O4 2-. Okay. So like that some symbols also be present. So monodentate ligands means they having one donor atom is present, can donate one pair of electrons to the central metal atom. Those ligands are called monodentate ligands. Monodentate ligands. Okay. See the examples for monodentate ligands. Next, bidentate ligands. Bidentate ligands means while in the side we can understand very easily. Bidentate ligands mean the ligands which are having two donor atoms are present. The ligands which are having two donor atoms are present can donate two pair of electrons to the central metal atom. Means they are donating two pair of electrons to the central metal atom means they forms two dato bonds. Monodentate ligands can forms one dato bond. Bidentate ligands can forms two dato bonds. Tridentate ligands can form 3 dato bonds. Tetradentate ligands can form 4 dato bonds. Means they have 4 donor atoms are present and they donate 4 pair of electrons. Those are called tetradentate ligands. Okay. See, bidentate ligands mostly for our level mostly they will give in examples monodentate ligands as well as bidentate ligands only they will use mostly. Mono and bidentate ligands. See, oxalate ion. Oxalate ion means C2O4 2-. Oxalic acid. Oxalic acid ionized gives C2O4 2-. Oxalic acid forms H2C2O4. It gives 2 H plus ions plus C2O4 2- is called oxalate ion. So its name is oxalato. Shortcut representation is OX. OX is called oxalato. Next, it is a negative ligand. What is the 2 units negative charge is present? That's why, see, generally neutral ligands oxidation state is 0. Mono negative ligands oxidation state is -1. Bi-negative ligands oxidation state is -2. Mono positive ligands oxidation state is +1. Bi-positive ligands oxidation state is +2. So whatever the charge is present on the ligands, that is equal to its oxidation number. It is equal to oxidation number. So oxidation number calculation is very important. Oxidation state or oxidation number of central metal atom in the given complex compounds, it is very important. In that case, the charges will help for you. Okay, NH3 is present in the molecule, its oxidation state is 0. Water is present, its oxidation state is 0. CO is present, oxidation state is 0. Cl is present, oxidation state is -1. NO plus is present, this oxidation state is +1. Here NO and NO2, they may act as positive ligands as they may act as a monopositive ligands also. Positive as well as neutral ligands. Positive as well as neutral ligands. That is special conditions only, ma'am. Under special conditions, NO has +1 unit positive charge present, then it is called nitrosonium ion. Means whenever positive ligands are present, ends with, while writing its IUPAC name, ends with IUM, we need to add nitrosonium ion. Nitronium ion. Nitronium. H3O plus hydronium ion. Hydronium. Hydronium, that is important. Negative ligands, while writing its name, ends with O. Positive ligands ends with IUM. Neutral ligands as same. Neutral ligands as same. So you remember the next concept IUPAC nomenclature will come. Okay, very very important. IUPAC nomenclature is also very very important for complex compounds. Okay, SO4 2 minus sulfato, CO3 2 minus carbonato. C. What is this? Glycine formula, we know that amino acids. Optically inactive amino acid is glycine. See here, this cross express ion then produce glycinato ion. So here oxygen is donor atom and nitrogen is donor atoms. Two donor atoms are present. That's why glycinato, symbol is GLY. GLY. It is a bidentate ligand. Two donor atoms are present. Okay. Dimethyl glyoxine. Dimethyl glyoxine. Oxines means what, ma? Carbon and nitrogen having double bonds and OH group is present. Those are called oxines. Dimethyl glyoxine. DMG. It is a bidentate ligand. Two oxygen atoms. So here oxygen is the donor atoms. Okay. Dimethyl glyoxine. Dimethyl glyoxine. These all are the bidentate ligands. And ethylene diamine, EN, hydrogen. Also two donor atoms are present. Those are bidentate ligands. Let's see. Next, polydentate ligands. Polydentate ligands means 3 donor atoms, 4 donor atoms, 5, 6, like those all we are considered as polydentate ligands only. So the polydentate ligands, 3 donor atoms are present, it is called tridentate ligand. 4 donor atoms are present, tetradentate ligands. 5 penta, 6 hexadentate ligands. Okay, see. Already here I gave one example. IDA means Amino diacetato. Amino diacetato. NH group is present, it is called amino. Diacetato. O minus. See, here this oxygen is donor atom, nitrogen and this oxygen. 3 donor atoms are present. That's it is a tridentate ligand. Amino diacetato, IDA. Shortcut name is symbol is IDA. Amino diacetato. And diene, diethylene triamine is also belongs to tridentate ligand. Means 3 donor atoms are present. Diethylene. See, actually NH3 is present ethylene diamine, but diethylene means again one more ethylene group is attached to this nitrogen. Diethylene triamine. Its symbol is called diene. Diene is called is a tridentate ligand. 3 donor atoms are present. Okay. Next. Tetradentate ligands. Tetradentate ligands. Let's see. Tetradentate ligands. Tetradentate ligands means they contain 4 donor atoms, can donate 4 pair of electrons. 4 donor atoms present. Can donate 4 pair of electrons. Can donate 4 pair of electrons. Example C, NTA. Nitrito triacetate. NTA means nitrito triacetate. Triacetate. See, this nitrogen is one donor atom. This contains 3 acetate groups. CH2, CO minus, CH2, CO minus, CH2, CO minus. Nitrito triacetate, NTA, is a tetradentate ligand. 3 donor atoms are present. And triene. See, diene means diethylene triamine. Triene means triethylene tetraamine. Triethylene tetraamine. Triethylene tetraamine means NH2, CH2 bond NH, bond CH2, bond CH2, bond NH, bond CH2, bond CH2, bond NH. See, triethylene tetraamine. 4 nitrogen donor atoms are present. It is tetradentate ligand. So, tridentate, tetradentate, pentadentate and hexadentate ligands all we are calling as polydentate ligands. So, all we are calling as a polydentate ligands. Clear, ma? Let's see. One more important example, EDTA. EDTA. What is the full name of EDTA? Ethylene diamine tetraacetate. Ethylene diamine tetraacetate is known as a EDTA. Ethylene diamine tetraacetate or tetraacetate is known as EDTA. So it is a hexadentate ligand. Hexadentate ligand. See, ethylene diamine. Two amine groups having 4 acetate groups are present, here 2 and here 2. And nitrogen atoms also acts as a donor. So total 4 donor atoms, 6 donor atoms are present. 2 nitrogens and 4 oxygens. Total 6. That's why EDTA belongs to hexadentate ligand. So this is the classification of ligands based on number of donor atoms. Based on number of donor atoms, the ligands are classified into monodentate, bidentate, tri, tetra, like poly. So all tridentate, tetradentate, hexadentate, all ligands are belongs to polydentate ligands. All are belongs to polydentate ligands. Okay, clear? Next. Third one. Let's see. Based on nature of bonding. Based on nature of bonding. Nature of bonding. Based on nature of bonding, the ligands are classified into following types. One is chelating ligands. Chelating ligands. What is meaning for chelating ligand? Chelation means ring formation. Ring containing complex. See, generally, which ligands forms ring in their complex structures? Generally, if the ligands having two or more than two donor atoms are present, the ligands, otherwise two or more than two donor atoms containing ligands forms chelation with central metal atom. Central metal atom known as chelating ligands. And such complexes called as chelating complex. These complexes are called as chelating complex. So generally examples see for chelating complex are chelating ligands En, ethylene diamine, OX, EDTA, DMG. These all are acts as a chelating ligands. For example, Cu, En twice plus 2 means two ethylene diamine ligands are surrounded by the bonded with copper. Means how many day 2 bonds are present? Each En forms 2 day 2 bonds. Then total 4 bonds are present. Then what is the coordination number of copper in this complex compound? 4. Means they forms a ring. See, NH2. What is this bond line structure? It is CH2 groups. For understanding purpose, just I am writing. Otherwise, you write like this also, no problem. CH2. See here, 5-member ring is formed. 1, 2, 3, 4, 5. This is chelation ring. So generally, which ligands forms a ring with complex compounds? or chelation in complex compounds. Mostly bidentate ligands, tridentate ligands and polydentate ligands forms chelation by the donation of pair of electrons to the central metal atom. Such ligands are called chelating ligands and the complex is known as chelating complex. Such complex is known as a chelating complex. Okay. What are the chelating ligands? It is very important. Chelating ligands. Generally, chelating complexes are more stable. Chelating complexes are more stable when compared with normal complex because of they form ring. That is very important point. So, chelating complexes are more stable than normal complex compounds. Okay, students, remember that. Next, the second one is means based on the nature of bonding, the ligands are classified into mainly two types. One is chelating ligands, second one is ambidentate ligands. Ambidentate ligands. What is the meaning for ambidentate ligands? Ambidentate ligands means generally ambidentate ligands belongs to monodentate ligands only. The ligands having two donor atoms having their two donor atoms means what type of ligands? The monodentate ligands only. Ambidentate ligands means the monodentate ligands. Monodentate ligands. The monodentate ligands having two donor atoms present in which one donor atom linkage with central metal. Only forms bonding. One donor atom linkage or bonding with central metal atom known as ambidentate ligands. See examples. Generally, ambidentate ligands are present while writing its IUPAC name. We have to mention after the name of the ligand which atom is bonded with the central metal atom. That atom symbol we need to write. For example, metal is bonding with Cn. Means Cn group is present. Has two donor atoms are present. One is carbon, second one is nitrogen. Cn minus. Means here cyano is bonding with carbon. Means the metal is bonding with carbon. That's why cyano in bracket C we need to mention. Means carbon is bonding with central metal atom. MC. Isocyano. In which the bonded atom is nitrogen. The second example, thiocyano. MSCN. Thiocyano. The bonded atom is sulfur. NCS means nitrogen is bonded with metal. It is called isothiocyanate. In that the bonded atom is nitrogen. The same way NO2 group is also acts as a ambidentate ligand because nitrogen is bonded with metal as well as oxygen also bonded with metal. Oxygen also bonded with the metal. So nitrogen donor atom is present as well as oxygen donor atom is present. Two donor atoms are present, but in each one atom only bonded with central metal atom. Such type of ligands are called ambidentate ligands. Such type of ligands are called ambidentate ligands. Okay, these are the examples for ambidentate ligands. Okay, students, let's see next. So this is about the classification of ligands. Next, the next one is coordination number. What is coordination number? Coordination number is nothing but the number of day 2 bonds or the number of monodentate ligands. The number of monodentate ligands around the central metal atom is called coordination number. What is the importance of this coordination number? Coordination number is mainly useful. It is useful to predict the structure of complex compounds. The coordination number, based on the coordination number, structure of complex compound means based on the coordination number, we can identify structure of complex compound. Structure of complex compound. See, this coordination number is also called secondary valency. We also call it secondary valency. Okay. That gives the geometry of the complex compound or structure of the complex compound. See how to calculate coordination number. For example, monodentate ligands are present. Then coordination number is equal to. So generally, monodentate ligands have one donor atom is present. Then 1 into number of monodentate ligands. For example, two donor bidentate ligands are present, then two donor atoms are present, they form each bidentate ligand forms 2 bonds. That's why 2 into number of bidentate ligands. Bidentate ligands. If 3 are mixture of ligands are present, some of the monodentate, some of the bidentate ligands are present, then 1 into number of monodentate ligands plus 2 into number of bidentate ligands. So like that we have to calculate a coordination number. We have to calculate a coordination number. 3 are present, tridentate ligands are present, 3 into number of tridentate ligands. Tetradentate ligands are present, 4 into number of tetradentate ligands. Like that only we have to calculate coordination number. So based on the coordination number we can predict the geometry or structure of the complex compound, I said. If coordination number and geometry. Let's see. Coordination number is 2. The geometry is linear. Coordination number 3. Trigonal planar. Coordination number 4. If coordination number is 4 means 2 types of geometries will come. Depend based on the nature of ligand. What are the 2 types? One is tetrahedral. Tetrahedral geometry or square planar. Square planar. Coordination number 5. Trigonal bipyramidal. Coordination number 6. Octahedral geometry. So, based on the coordination number, we can predict the geometry of the complex compounds. Okay, ma'am. This is about a coordination number. So, how to calculate the coordination number? A ligand, a complex having both monodentate ligands as well as bidentate ligands are present. Then its coordination number is equal to 1 into number of monodentate ligands plus 2 into number of bidentate ligands. Then only we will get exact coordination number value. According to that coordination number value, we can predict its geometry as well as hybridization also. Linear SP, trigonal planar geometry SP2, tetrahedral SP3, square planar PSP2, trigonal bipyramidal geometry SP3D, octahedral. 2 types of hybridizations there will come. One is SP3D2 and D2SP3. So like hybridization also we can calculate. We can say based on its coordination number. Okay. Next. Oxidation number or oxidation state of central metal atom or central metal ion. So calculation of oxidation number is also important, ma'am. Oxidation number of central metal. Okay. What is oxidation number? Oxidation number is nothing but charge. Charge on the central metal is known as a oxidation state. How to calculate?